We have a shadow RAM. So we have a shadow of everything that's there. So we have a read-only memory that's mapped into the RAM section. So we can access that data quickly. We're not reading it from the BIOS all the time and wearing out. So when it boots up, it just sticks that stuff in RAM so that the rest of the system can access it. And then we have a video card in there with RAM, and we have a shadowing section for that as well. So we have something called shadow RAM. So that's how this works. So we actually use the video card's memory and we just map it to our memory. We don't actually access it from here like we do with the BIOS. And the physical chips are all mapped into our memory space through mapping or shadowing. So we have determining usable memory. So we have a memory type: conventional, upper, reserved, and extended memory, which we talked about previously. We have the HMA, which is the XMS here. And we have 640 kilobytes. We have so much used and so much free. We have an upper and we have a reserve. So there's different things that go in here. It's not significant that you know what it is, just give you an idea of what's happening here. So you have largest executable program size and the largest free upper memory block. So just to give you an idea. So we have a chapter summary here. The two basic computer memory types are ROM, non-volatile, which is read-only, even though really we have EEPROM, which is read-only, but it's electrically erasable. We can erase it and rewrite to it, but generally it's read-only, so don't confuse the two there. Generally, it's read-only memory. And sometimes some of the RAM is read-only, period. You cannot erase it sometimes, but generally most of them you can erase nowadays. Everything's configurable, right? And RAM is always volatile. If you turn off the power, the RAM is gone. You can't depend on that data to stay there. It might, but it might not. RAM is packaged in a variety of designs. We have the SIMs and DIMMs and even bigger ones today. We discussed installing SIMs and requires ESD, electrostatic detection, or discharge protection. ESD, electrostatic discharge protection. When we're inserting the SIM or DIMM, we want to do it at a 45-degree angle. Not quite at a 45, but you can start there. And then cache memory enhances performance. It speeds things up, right? So as data moves closer to the processor, we're going to store it in faster and faster cache so the processor can as it needs it, right? So that's how that works. And we talked about the reason that it's necessary is because if the processor ever becomes idle, the system will reboot. And when it's not doing anything, which is, if you look in your process list, which we'll talk about later, the system is idle most of the time. Your system should be idle about 60% of the time. If it's not, you're probably doing something wrong. As far as the CPU goes, so it's just sitting there executing that no-op instruction over and over and over. Hexadecimal code simplifies binary code notation. So we talked about the hexadecimal versus binary representation. And we talked about the abstraction. So everything is represented in a computer with a 0 and 1, but to us, we don't like zeros and ones very much, so we like to abstract that into simpler things that we can understand. For example, hexadecimal number systems. Memory allocation has been simplified under Microsoft Windows. The more advanced versions of Windows and the new BIOSes, everything is easier to understand. There was a time when we had to make sure that we literally said, load this into high memory, load this into the first stage of memory, the conventional memory, the 0 to 640K, you actually had to tell it where you wanted it to go, to HMA or conventional. We don't have to do that today. It's done for us. And then that's pretty much it for this chapter.